Okay, this is a short narration on strategies to improve ankle-foot function after Achilles rupture, particularly plantar flexion. So the plantar flexion demand during walking is summarized in this table. We can see that the muscle action is eccentric to concentric, so it's a stretch shortening cycle. The range of motion necessary is 10 degrees of dorsiflexion to about 20 degrees of plantar flexion and more for running. And the angular velocity is about 300 degrees per second, so super rapid. And the loading is at least 100% body weight and much more for functional tasks. So we kind of take a look at this. 3 phases of running, we can kind of associate that with the function. So at initial contact, we basically have the ground reaction forces at the heel going up toward the center of mass. It's behind the ankle joint center, okay? And so basically it's plantar flexing the ankle, so we need our ankle dorsiflexors at initial contact. So ankle plantar flexion comes in after initial contact and the foot's flat. And so the center of mass here is kind of progressed over the body, over the foot, during running. Its center of pressure is anterior to the ankle joint center. And so essentially it's causing a dorsiflexion moment. So the internal moment is plantar flexion. So this is that eccentric control because the shank is angling forward. So that's causing dorsiflexion over a fixed foot. All right, and that's eccentric control. And then toward the end of the running phase in this particular case, but it's the same for walking, we have the center of mass is in front of the stance limb, and we're in single limb support. And during that period, we have this kind of plantar flexion of the ankle. That plantar flexion of the ankle moves the center of mass up and forward for forward progression. We can kind of see that, again, we have this now, the moment arm here from the ankle joint center to the ground reaction force is quite large. So this requires a lot of ankle plantar flexion torque. And essentially what we're seeing here is that internal torque is in plantar flexion to oppose this dorsiflexion that ground reaction force is causing. So that's our goal, is to get to this effective push-off. Means somebody can, kind of push their leg into ankle plantar flexion when the load on a forefoot is at least a body weight or more. So a great idea is to do partial weight bearing, kind of heel rise types of tasks. And so this kind of models this function on a sled. Like this is a total gym type of device that the person can lay on, and then you can put it at different angles so you can have different amounts of body weight. And so 45-degree angle would be about half body weight, and fully upright would be 1 body weight. So you can kind of see here, you could just do simple heel rises, or you could do some type of bounding exercises, which then recruits the eccentric, concentric motor pattern that the ankle uses during functional tasks. And that's why this particular device is being highlighted here. And this is actually being proposed for stroke patients, but it could be just as easily applied to patients that had a rupture or Achilles tendinopathy or something like that. You can also try to use a trampoline, but now we're getting into kind of full body weight function, okay? And then, you can do lunging exercises and different kinds of weight-bearing things, and we'll do those in class. During running, there's this kind of subtalar inversion that the foot needs to function. And so we can kind of see that there's inversion at initial contact and eversion throughout stance until heel off, and then basically you have return to inversion again at initial contact. And then the muscles that are controlling that are really the tibialis posterior, anterior, and then the peroneus longus, which isn't shown here. But those muscles kind of give you that inverter-everter control. And so what we also want to do is just kind of visualize this. So essentially here's the foot with a little bit of inversion at landing. So that means the center of pressure in the forefoot is lateral. Okay, and this is important for exercise because we're going to use this pressure pattern when we do plantar flexion. So the pressure pattern is, it starts in lateral. As you go into eversion, it's going to move medial. And then, as you go to kind of push off, it's going to be like under the second toe or something like that, and you're going to push off. So you need both plantar flexion with lateral pressure and plantar flexion with medial pressure to function normally. So we need both the subtalar joint and the ankle joint to work together to get the proper foot function in training. And so here's an example, of just how the foot goes into eversion toward mid stance in running. So the training is going to be partial weight bearing to full weight bearing, and we're going to start supine with TheraBand. But what I want to really emphasize is that just won't get the job done. You need a lot more load for the ankle, and you need a lot of different kinds of contractions, where TheraBand supine is all concentric, and there's no real recoil effect or motor control effect on the recoil of the tendon. So that's not going to get the job done in terms of translating to function. Now you can also move to a seated position with the knee bent, but that doesn't get the gastroc. But it does allow you to train better. So here you can do seated with weight on the thigh, and this could be a 45-pound kind of weight that you could get from a weightlifting bar. And then basically you can do medial and lateral, kind of pressures under the forefoot to get to coordinate the plantar flexion with medial and lateral transfer of weight, which the patients will need. You can also do something where they're reaching overhead if their shoulder function's okay, and you can do like on a door is easy for them to do at home, or if there's some kind of pipe they can reach in their basement or something like that, that can work. You also can use parallel bars, and that works really well for helping people in the clinic. Or you can do like what we saw in the training thing, you can do partial weight bearing. Is really easy to implement if you have something like a total gym or an incline press, because then you can either load weight up on it if it's a leg press machine, okay, or if it's total gym, you can just vary the angle that they're working at, knowing that 45 degrees is about half body weight. The other way you can kind of do partial weight bearing is to use a bike. And so you can move the seat up really high so that they're basically trying to get more out of their ankle. And then essentially, or you can do it standing, but the key is where their foot is. If their heel is on the pedal, then there will be no work done in the plantar flexors. And if the ball of their foot is on the pedal, then the potential for work is on the plantar flexors, but they have to maintain the pressure on the forefoot, and then they also have to hold their ankle in plantar flexion to ensure that the calf is engaged as they do the bike. And so those are important, kind of pearls to have to get the bike to be more effective for calf retraining. But the bike can be really good in terms of a HIIT workout, or just kind of a continuous, kind of 20-minute range to give the calf endurance that will translate to walking different tasks. The reason the bike is really good is because it integrates the calf work with the knee extensors and the hip extensors, which is what they'll need for like running and walking and other functional sports tasks. And then finally, there's kind of functional movements that we'll try to do. To me, these are more difficult to manipulate, but they're commonly, we have to include them in different things we do with patients to try to see how these different activities are translating to function. And then finally, once you get to full body weight, you're doing things like the trampoline, you're working on simulating gait, heel-toe gait, which is, important for patients. And then we have step downs, and then combining, heel rises with inversion and eversion, or pressure moving from the medial to lateral side of the foot is really difficult. So we can kind of look at the protocols that have been given and ask ourselves, like, what part of these protocols are really about training the calf muscle contractile element, meaning are they trying to hypertrophy the contractile element, or are they doing anything to try to engage control of the spring of the Achilles tendon so that motor control can be returned and their function can improve. And I would kind of look at these and see if what you see in terms of those strategies. And the same thing here for this 4 to 6 week interval. And I just want to remind everybody about what controls the arch of the foot. And this is an experiment I did a few years ago. We were looking at foot function, and what you can kind of see here is this is a cadaver foot, and we have all these kind of markers on them. And I want you to watch the arch of the foot as I internally and externally rotate the tibia. And what you see there is as I externally rotate the tibia, the arch raises, and as I internally rotate the tibia, the arch lowers. And so this is just to remind everybody that like the muscle controls are really, really important for the foot, but the position is also of the tibia and how that rotation controls the foot is also just as important. So as we're training people to kind of restore plantar flexion push off, we need them to do the push off when their kind of foot arches raised. And so basically that's going to be restored by controlling the pressure from the medial to lateral side. So we need them not just to have push off, but we need them to have push off with the ability to push on the forefoot either on the medial or lateral side. And that's what's going to give us this control of the arch of the foot.